Question 25. The Leaning Tower of Pisa in Italy is known for a slant, which occurred after its construction began. The angle of the slant is 86.03 degrees from the ground. The low side of the tower reaches a height of 183.27 feet from the ground. Determine the slant height x of the low side of the tower to the nearest hundredth of a foot. So for this question, since we know that this is a right triangle, we can just use trig, and we're going to be using this angle right here. So this side is always going to be the hypotenuse, this side is going to be the opposite side, and this side is going to be the adjacent side. So we can just do sine of 86.03 degrees is equal to 183.27 feet over x, and we can just solve for x. Okay, you should get x is equal to 183.71 feet as the answer. Question 26. In the diagram below, quadrilateral ABCD is inscribed in circle O, and these arc measures are all in a ratio like this. Determine the state of measure angle B. So we're trying to find this angle right here. So it says that it's in a ratio of 2, 3, 5, and 5. Measure angle B is going to be equal to half the measure of AC, right? Because it's an inscribed angle. So that means that if this was like 100 degrees, this would be 50 degrees, right? So since we're trying to find the whole arc degree for AC, we just combine 3 and 2. So this would be 5. So that means that the ratio for all these arc measures, it would be 5 to 5 to 5, right? That means that the circle is being split into 3 equal sections. We can take the total degrees of a circle, which is 360 degrees, and just divide it by 3, and we get 120 degrees. So you know that this is going to be 120 degrees, this is 120 degrees, and this whole green arc is also going to be 120 degrees. So again, to find angle measure B, it's going to be half of the green arc right here. So we can just do 120 divided by 2 is equal to 60. So measure of angle B is equal to 60 degrees. Question 27. In the diagram below, a right circular cone has a diameter of 10 and a slant height of 13. Determine and state the volume of the cone in terms of pi. To find the volume of a cone, we can use this equation right here. For this equation, we need to use the height, which is not given to us, since we're only given the slant height, which is not the same thing, and also the diameter. But using these two values, we can actually find the height, right, by just taking out this cross section right here. And knowing that this is a right circular cone, we know that this angle right here is a right angle. Knowing this is a right triangle, we can just use the Pythagorean theorem to find the height. So a squared plus b squared is equal to c squared. So we know the slant height right here is 13. And instead of using 10, we're going to have to use the measurement for only half. So it would be 5. And then this could be a. Right, so a squared plus 5 squared is equal to 13 squared. And we can just solve for a. So a is equal to 12, which means the height is equal to 12. So we can just plug in everything to the volume equation now. V is equal to 1/3 pi. We know the radius is 5 because the radius is half of the diameter. So 5 squared times h, which we know is 12. And then we can just solve for v. It says to leave the answer in terms of pi, so we're just going to leave the answer at 100 pi. Question 28. In the diagram below, parallelogram EFGH is mapped onto parallelogram IJKH after a reflection over line L. Use the properties of rigid motions to explain why parallelogram EFGH is congruent to parallelogram IJKH. So for these type of questions, we need to know what a rigid motion is and what it has to do with congruence. So we know this is a reflection, so we have to include that in our answer. So we can say that reflections are a rigid motion that preserves distance and animation. Right? That's just the meaning of what a rigid motion is. We have to relate that to congruency, right? So we just say that this means that congruency is also something like that, but make sure you don't write outside of the box like me. Question 29. Izzy is making homemade clay pendants in the shape of a solid hemisphere as modeled below. Each pendant has a radius of 2.8 centimeters. How much clay to the nearest cubic centimeter does Izzy need to make 100 pendants? So first we can find the volume for one of the pendants. Right, so the volume of a hemisphere is equal to 1/2 times 4/3 times pi times radius cubed. So we can just plug in the radius, which we know is 2.8, and just solve for the volume. So you should get this for the volume of one pendant. And for this question, we need to find how much clay is needed to make 100 pendants. So all we need to do is just multiply that by 100. Since it says to round to the nearest cubic centimeter, the answer would be 4,598 cubic centimeters. Question 30. Determine and state the coordinates of the center and the length of the radius of the circle whose equation is x squared plus y squared plus 6x equals 6y plus 63. So basically what this question is saying is we use this equation, and from that we need to get the center and also the radius. So to do that we need to know what the circle equation is. So the circle equation is x minus a squared plus y minus b squared is equal to r squared. So what the circle equation includes is the center and the radius, right? Because the center is AB and the radius is just r. All we need to do is just take this equation and put it into this form. And to do that, we just need to complete the square. So we want to isolate the 63. And then we want to group together the x and the y's. And to complete the square, we need to find the values here that will make these two sections into perfect square trinomials. So to do that, we just take the b values and divide by 2 and square it. So for the x section, it's going to be 6 divided by 2 squared, which is equal to 3 squared, which is equal to 9. So this value right here will be plus 9. And we also need to do plus 9 on this side as well. And then for the y section, it's going to be negative 6 divided by 2 squared, which is equal to 3 squared, which is also equal to 9. So we just do plus 9 over here, and also plus 9. So now these two sections are all perfect square trinomials, which means that they can be factored into this form. So when factored, this section is going to be x plus 3 squared, and this section is going to be x minus 3 squared. And then 63 plus 9 is equal to 81. So we also have to put 81 into this form to find the radius, right? So 81 is just going to be 9 squared. So now that we've changed the equation into the circle equation, we can easily find the center and the radius. So the center, again, is AB. So the center for this circle is equal to negative 3, 3. And then the radius is super easy. The radius is just 9. Question 31. Use a compass and a straight edge to construct a line parallel to line AB through point C, shown below. Okay, first you want to take your straight edge and draw a line through point A and point C. And then you want to take your compass and put the sharp point on point A, and then draw an arc that passes through line AB, and also the line that we drew earlier. Without changing the size of the compass, you want to move the sharp point to point C, and you want to draw a similar arc. Still having the sharp point on point C, you want to change the size of the compass and draw an arc right here where the arc and the line intersects. And you want to take that and copy it over here. Something like this. And taking your straight edge again, you want to line up the intersection and point C, and you can draw a line. And that line is going to be parallel to line AB. Question 32. As modeled below, a projector mounted on a ceiling is 3.74 meters from a wall where a whiteboard is displayed. The vertical distance from the ceiling to the top of the whiteboard is 0.41 meters, and the height of the whiteboard is 1.17 meters. Determine and state the projection angle theta to the nearest tenth of a degree. So we are trying to find this angle right here, and we can't use trig for this because the triangle the angle is in is not a right triangle. So what we can do is we can see that this is a right triangle, right? So we can find this angle, which I'm going to call theta 2, and then we can subtract this small angle, which is also a right angle. Okay, to find theta 2, we're going to have to add these two side lengths together. which is equal to 1.58 meters. And then from that we can do tangent of theta 2 is equal to opposite over adjacent. 1.58 is the opposite and 3.74 is the adjacent. So then we just solve for theta. So that's what you should get for theta 2. Now we're going to try and find theta 3, and what we're going to do is just tangent of theta 3 is equal to opposite over adjacent, so 0.41 over 3.74. And then we just solve. Okay, now we have to try and find theta, and all we need to do is just do theta 2 minus theta 3. So theta 2 is 22.902 minus theta 3, which is 6.256. And you should get around 16.646. So theta to the nearest tenth of a degree is going to be equal to 16.6 degrees. Question 33. Given parallelogram PQRS, line QT is perpendicular to line PS, line SU is perpendicular to line QR. Prove that PT is congruent to UR. So first we can just draw the diagram out for proof, and also just write down what's given to us. Okay, so our objective is trying to prove this line congruent to this line. What we need to do is just to prove triangle RUS congruent to triangle PTQ. Since it's given that there are perpendicular lines, we can say that this angle right here is congruent to this angle because they are right angles. So first, we want to say that they are right angles, right? And they are right angles because of the perpendicular lines. Then you need to say that those two angles are congruent to each other. Then we can say that these two lines are congruent to each other because it's given that the shape is a parallelogram, right? And opposite sides of a parallelogram are congruent to each other. We can also say that this angle right here is congruent to this angle because in a parallelogram, opposite angles are congruent to each other. Since we have angle side proven to be congruent to angle side, we can say that those two triangles are congruent to each other. Now we can say that line RU is congruent to TP because of CP-CTC. Question 34. A concrete footing is a cylinder that is placed in the ground to support a building structure. The cylinder is 4 feet tall and 12 inches in diameter. A contractor is installing 10 footings. If a bag of concrete mix makes 2/3 of a cubic foot of concrete, determine and state the minimum number of bags of concrete mix needed to make all 10 footings. For this question, we can start off by finding how much concrete is needed to make one footing. So to do that, we just need to find the volume of the cylinder, right? It's given that the height is 4 feet, and the diameter is 12 inches, which is also just 1 foot. So to find the volume of a cylinder, we use this equation right here. Remember that the radius is half of the diameter, and we're given that the diameter is 1 foot. So all we need to do is just 1 divided by 2, which is also 0.5. So now we just plug in all the values into the volume formula. The volume of one footing should just equal pi. So the amount of concrete needed to make 10 footings is just 10 pi. And since one bag only makes 2/3 of a cubic foot of concrete, we just divide that by 2/3 to see how many bags we need. So once you divide that, you get around 47.123. And it says the minimum number of bags. And we're obviously going to round up because if you just say 47 bags, it won't be enough to make all 10 footings. So always round up for questions like these. So you will have 48 bags. Question 35. The coordinates of the vertices of triangle ABC are A, -2, 4, B, -7, -1, and C, -3, -3. Prove that triangle ABC is isosceles. So to prove a triangle is isosceles, we either need to prove that two angles are congruent to each other or that two sides are congruent to each other. And since we're just giving coordinates of the vertices, we really can't do anything about finding the angles. So we're just going to have to find the distances between the vertices to figure out if any of them are congruent. So the distance formula is equal to, and now we just find the distances of each side. So the distance of AB, we're just gonna plug in the coordinates and solve. And also remember to write pretty small for these type of questions because you kind of need to write a lot. Okay, and then we can do line AC. So we can see that distance of AB is equal to distance of AC, which means that line AB is congruent to line AC. So therefore, triangle ABC is isosceles. Say the coordinates of triangle A prime, B prime, C prime, the image of triangle ABC after translation 5 units to the right and 5 units down. So the coordinates for triangle ABC, A is -2, 4, B is -7, -1, and then C is -3, -3. Okay, so to turn A into A prime, the translation 5 units to the right and 5 units down. So we just do -2, 5 units to the right is going to be +5, and 5 units down would be the y value -5. And then you're going to get the coordinates 3, 1. And then we just do the same thing for B and C. We do +5, and then we do -5. Okay, so you should get those 3 coordinates for triangle A prime, B prime, C prime. Question 35 continued. Prove that quadrilateral A prime, C prime, C is a rhombus. So the coordinates for A is -2, 4. A prime is 3, -1. C prime is 2, -8. And then C is -3, -3. So to prove a quadrilateral to be a rhombus, we need to prove that all 4 sides are congruent to each other. So we're going to have to use the distance formula again. Okay, distance of AC we know is radical 50 because we did it in the previous part of this question. Distance of A prime, C prime, it's also going to be radical 50 because A prime, C prime is the result of AC after a translation, and we know that translations preserve distance. Distance of A prime, we're going to have to plug in the coordinates into the distance equation and solve. Okay, so we get radical 50 for the distance of A prime, and now I have to do C prime. Okay, so you should get radical 50 for that as well. And since we've proven all sides to be congruent to each other, we can say that all 4 sides, so therefore